Hello friends, welcome to this AWS series. Today we will understand what AWS accounts are and why organizations need different AWS accounts in the first place. Well, when we create an AWS account for the first time, AWS creates a root account user. For learning purpose, you might operate everything within a single account. However, in real-world organizations, a single account is usually not enough. Most companies use multiple AWS accounts to manage different environments and workloads. That's why it's very important to understand the features and benefits that AWS accounts provide. Well, when we are just getting started with AWS, we typically create a single account. But as a company grows, it needs multiple environments. So we can create multiple accounts with respect to each environment. For example, for development environment, we can create dev account. For system integration and testing environment, we can create SIT account. For user acceptance testing environment, we can create UAT account. For production environment, prod account. The same way for disaster recovery environment, we can create DR account and so on. By creating separate AWS accounts for each environment, resources remain isolated from one another. This isolation improves security, simplifies management, and reduces the risk of accidental changes affecting critical environments. As organizations scale, they may end up managing tens, hundreds, or even thousands of AWS accounts. At a high level, you can think of an AWS account as a container for identities and resources. When I say identities, I mean users that can log in to AWS and interact with AWS services. So an AWS account contains identities that can access the account and resources that are provisioned inside the account. So keep this simple idea in mind throughout the course is that an AWS account is a container for identities and resources. Now, when we create an AWS account, we provide an account name, a unique email address, a payment method, typically a credit card. For example, if you are creating a production account for a company called Cognexa, we might name the account Cognexa-prod. We would then provide a unique email address specifically for that AWS account along with a credit card. One important point to remember is that the same credit card can be used across multiple AWS accounts, but the email address must be unique for every AWS account. So in other words, you need a separate email address for each AWS account that you create. The email address provided during account creation is used to create a special identity known as AWS Account Root User. Every AWS account has exactly one root user. For example, let's say I have created a production AWS account for the Cognexa organization. That production account will have its own root user, and that root user can log in only to that specific production AWS account. In a real organization, you will typically have multiple AWS accounts such as development account, SIT account, UAT account, production account, and so on. Each of these AWS accounts will have its own unique root user and its own unique email address. This means the production root user can access only the production AWS account, while the development root user can access only the development AWS account. These root users are completely separate from one another because they belong to different AWS accounts. Now, the root user has full control over its AWS account and all the resources within that account. In fact, the root user always retains full administrative access to the AWS account it belongs to. This is exactly why we need to be extremely careful with root user credentials. If someone gains access to these root users' username and a password, the consequences can be severe. Since the root user has unrestricted access, those credentials could potentially be used to modify, delete, or destroy resources within the AWS account. For this reason, AWS best practice is to secure the root user with a strong password, enable multi-factor authentication, and avoid using the root user for day-to-day administrative activities. Next, the credit card that you provide while creating an AWS account becomes the payment method for that account. This payment method is used to pay for any AWS resources that you create within the account. If those resources are billable and generate usage charges, then AWS bills that usage to the payment method associated with the account, which is typically a credit card. As we know, AWS follows a pay as you go or pay for what you use pricing model. This means you are generally charged only for the resources that you consume. For example, if you use a particular AWS service for just 2 minutes, you are typically charged only for that usage based on the service's pricing model. Now, one more thing that makes AWS very attractive is that many AWS services include a certain amount of free usage every month. This is known as the AWS free tier. The free tier allows you to explore and learn AWS services without incurring charges, provided your usage stays within the free usage limits defined by AWS. Once those limits are exceeded, standard service charges begin to apply. Now let's talk about security. As we learned earlier, the account root user has full control over its AWS account, and this access cannot be restricted. Because of this, securing the root user is extremely important. One of the first security best practices recommended by AWS is to enable multi-factor authentication (MFA) for the root user. Let's see how to do that in a demo. Well, I have already created an AWS account called Cognexa Parent Account. Here, Cognexa is the name of my company, and this account acts as the parent account for the organization. To configure MFA, click on your account name in the top right corner of the AWS Management Console and then select Security Credentials. On the Security Credentials page, scroll down to Multi-Factor Authentication (MFA) section. From here, you can configure MFA devices to the root user account. Notice that AWS allows you to register multiple MFA devices. This provides additional flexibility and can help prevent lockout situation if one device becomes unavailable. To add a new MFA device, click on Assign MFA Device. In the wizard, enter a device name, for example, ABC-iPhone. Next, select Authenticator App and click Next. AWS will now generate configuration information for the virtual MFA device, including a QR code. This QR code contains the secret configuration information that your authenticator application will use to generate one-time password. Now open your preferred authenticator application on your mobile device. If the application supports multiple accounts, choose the option to add a new account or device. Back in the AWS wizard, scan the displayed QR code using the authenticator app. For that, click on Show QR code. Once the QR code is scanned successfully, the authenticator app will start generating one-time passwords. Here, enter the first one-time password shown in the authenticator app into the MFA code 1 field. Then wait for authenticator app to generate the next code, which usually takes 30 seconds. Enter the code into the MFA code 2 field here. After entering both codes, click Add MFA. Once the setup is completed successfully, you will see the device listed under the multi-factor authentication section. For now, I am cancelling it because I have already added my devices. From here, you can manage your MFA devices, add additional devices or remove existing ones if required. And that's it. MFA has now been successfully configured for the root user. Well, another way to improve security is by creating additional identities inside an AWS account that can be controlled and restricted as needed. This service is called IAM, which stands for Identity and Access Management. Using IAM, we can create and manage identities within an AWS account. We will explore IAM and IAM Identity Center in much greater detail in upcoming sessions, but for now, let's understand the basic concept. Well, IAM allows us to create different types of identities such as IAM user, IAM groups, IAM roles, IAM policies. Don't worry about the details right now. We will cover each of these individually in later sessions. At this stage, the important thing is to understand is that IAM identities start with no permissions by default. Unlike the root user, they cannot access AWS resources unless permissions are explicitly granted to them. Depending on your requirements, you can grant these identities full access, limited access, or highly specific permissions within that AWS account. Just like the root user belongs to a specific AWS account, IAM is also an account level service. This means that by default, IAM identities created in one AWS account cannot access resources in another AWS account. For example, if you create an IAM user in a development account, that user cannot automatically access resources in the production account. Of course, AWS does provide mechanisms for cross-account access. Using services such as AWS Identity Center and cross-account roles, we can allow users to access multiple AWS accounts within an AWS organization. We will cover those topics later in this course. For now, I want you to keep one simple idea in mind. Think of an AWS account as a container. The identities, resources, and the services that exist inside that container are isolated from other AWS accounts unless you explicitly configure access between them. Another key point to remember is that IAM identities start with 0 permissions by default. The only identity that has unrestricted access from the beginning is the account root user. For every IAM user, group, or role, permissions must be explicitly granted through IAM policies. Now, organizations create multiple AWS accounts not only for different environments such as development, SIT, UAT, and production, but also for different teams, business units, projects, or even entirely different products. This separation helps improve security, governance, billing, and operational management. By default, AWS follows a security principle known as implicit deny, which means access is denied unless it is explicitly allowed through permissions. This security-first approach is one of the reasons AWS is trusted by organizations of all sizes around the world. So, AWS accounts are a fundamental building block of AWS, and understanding them is extremely important. Whether you are a solution architect, DevOps engineer, cloud engineer, AWS administrator, system administrator, or developer, you should be comfortable with how AWS accounts are structured and how they are used effectively. For now, I encourage you to create an AWS account if you haven't already done so, and enable MFA for the root user as we demonstrated earlier. In the next session, we will continue building on these concepts and dive deeper into AWS identity and access management. If you found this helpful, don't forget to like, share, and subscribe. Thank you for watching, and as always, happy learning.